Okay, so as I've already told you earlier, there are three factors affecting band broadening. What is band broadening? So remember, we want our, what we call that, we want our shape or peak to be like this. It must be symmetry. Okay, but when it becomes like this, means it is band broadening. Okay, so this is band broadening. Okay, and there are three factors affecting band broadening. Number one is multiple path. Okay, so number one is multiple path or eddy diffusion. The A term. We call it eddy diffusion that we have discussed earlier. Okay, so this one, we have discussed this earlier. Okay, eddy diffusion. So what happened when there are a lot of, what we call that, when there are a lot of away due to particles here, particles. So the solid will move or travel through different paths. So it will reach at the detector at different times. So it will give you a band broadening or a broadband. Okay. So the second factor is the mass transfer factor. Okay, so mass transfer factor. So for mass transfer factor, it is C term. Second factor is C term. It is mass transfer. And for mass transfer, okay, for mass transfer, this divided into two: mobile phase mass transfer and also stationary phase mass transfer. So what is actually mass transfer? Okay. So saya akan terangkan ni sebab dekat situ dia macam confused sikit. Okay. So your analytes, okay, dia akan be partition between two phases. Your stationary phase and also mobile phase. So here is your mobile phase. Here is your stationary phase. Okay. So these two, your analyte must reach equilibrium with this. Baru dia boleh pilih lah dia nak reach which one. Okay, so dia tak boleh lalu macam tu je. Kalau dia lalu saja, dia tak ada langsung interaction, dia akan keluar as dead time. Yang kita dah belajar dulu, dead time. So dia keluar tanpa ada any interaction. But it should interact and it should, what we call that, should interacts and dia pun mesti ada retention. And then baru dia boleh keluar. It must reach equilibrium. So for mobile phase mass transfer, it is a process of peak broadening. It is caused by the presence of different flow profile. Means you are going to look at different flow rate within the channel or between particles of the support in the column. So a solid in the center of the channel moves more quickly than solid at the edges. It will tend to reach the end of the channel first, leading to band broadening. Okay, so what happened? For example, we have this. This is our column, right? Okay, so ada yang kat tengah, ada solids in it, and then there are solids at the edges. So when the flow rate of the gas go through, what happened? Yang dekat tengah ni will move faster as quickly as compared to the one at the edges. So ini akan pergi dulu. So it reach detector first and then followed by at the edges. So what happened? Bila dia sampai tak sama, then it will become broadband. Okay. So other thing is that ini the degree of band broadening due to eddy diffusion and mobile phase mass transfer depends mainly on the size of the packing materials and also the diffusion rate of the solute. Okay. Kita tengok macam ni. Okay, so this is your mobile phase. This is your stationary phase. Stationary phase tak bergerak, mobile phase bergerak, right? Awak kena faham macam ni, your end light, dia mesti reach equilibrium dulu. Dia mesti interact with both. Maksudnya, dia reach equilibrium and then dah reach equilibrium baru dia akan eluted. Dia tak boleh keluar terus kan? Okay, so supposedly dia akan dapat macam ni. Macam ni. Okay. However, what happen bila diffusion, kan dia cakap diffusion rate of the solid. Diffusion ni tak cukup, tak sempat nak diffuse, tak sempat lagi nak diffuse, nak reach equilibrium. Daripada atas sampai bawah ni tak sempat nak reach equilibrium. And then the flow rate is high. The flow rate or the velocity is high. So dia akan swept ahead, dia akan tarik ni. Kita punya analyte tu, so dia jadi macam mana? Sorry. So dia jadi macam ni. So your stationary phase is here. Okay, so baru nak interact sini, baru nak diffuse dia, and then suddenly the velocity is high, so dia akan bawa mobile phase tu akan bergerak ke depan. Contohnya macam ni. Dah sampai sini mobile phase tu. Okay, tapi there are still analytes yang tak habis nak interact, tak habis nak diffuse lagi, yang stay with the stationary phase. So what happened? This process akan buat band broadening. Why? They are the one at the front thing here. Okay, so dia akan lekat lagi kat bawah ni. Tapi yang depan ni dah swept ahead. So dia akan jadi band broadening. Sebab di masa dia tertinggal tapi dah laju, dia tak sempat reach equilibrium. So dia akan jadi besar, tertarik. Okay. So, different solute molecules spend different length of time in stationary phase. They also spend different amount of times on the column, and this will give rise to the band broadening. So, the degree of band broadening due to stationary phase mass transfer depends on retention and diffusion of the solute. Dia retain lama sangat tak boleh. Dia reach equilibrium, dia boleh kena gerak. Diffusion kena cepat supaya bila mobile phase sudah gerak, dia dah tak tertinggal dalam stationary phase. Dia bergerak sama dengan mobile phase. And then the flow rate of the solute through the column. So the flow rate mesti optimum flow rate. Maksud dia tak boleh terlampau laju, tak boleh terlampau slow. Dia kena optimum. Elok je reach equilibrium, dia bawa ke depan. Then the kinetics of interaction between the solute and also the stationary phase. Okay, so this is the second factor that contribute to band broadening. And the last factor is B term. Okay, so normally kalau kita belajar chromatography, this is the second factor, tapi tak apalah sebab saya ikut punya nota. So B term is what? Longitudinal diffusion. Okay, so longitudinal diffusion is band broadening due to the diffusion of the solute along the length of the column in the flowing mobile phase. So when we talk about diffusion, what is actually diffusion? Okay, so diffusion, if the movement of solute, movement or migration of solutes daripada mana? From high concentration to low concentration. Okay, so let's say here, this is your solutes. Okay, so this solute will migrate, it will diffuse. Diffuse ke mana? Ke low concentration. So dia akan pergi macam mana? Daripada sini dia akan pergi ke sebelah sini. Ni kan low concentration. So daripada sini dia akan diffuse, pergi ke sebelah ni. Diffuse, bergerak ke sebelah ni. So this diffusion, okay, will make the band broad. So dia diffuse, tapi keluar-keluar, so jadi broad band lah. Tapi kalau dia tak diffuse, look at this. For this one, it diffuse. So you get broadband. Okay. So diffusion, the degree of band broadening due to longitudinal diffusion depends on the diffusion of the solute. So depends whether your solute is gas or liquid. So tengok kan. So kalau your solute is gas, of course diffusion is high. Dia lagi cepat diffuse, bergerak ke tepi, because it has high kinetic energy. But if it is liquid, diffusion is lesser. Dia akan gerak juga diffuse tapi kurang. So sempatlah, tak sempat diffuse, dia dah keluar reach detector. Tapi kalau gas, dia akan diffuse more before reaching detector. So dapat band broadening. So diffusion of the solute. Second thing is the flow rate of the solute through the column. So as you can see here, dua-dua depends on flow rate. B term dengan C term depends on flow rate. So for this one, macam mana kita nak avoid band broadening happen due to longitudinal diffusion. Kita tak nak dia spread kat tepi ni or diffuse. Kita kena gerak lajulah supaya dia sampai detektor cepat. So macam mana kita nak lajukan dia? By increasing the flow rate. Bila kita tinggikan flow rate mobile phase kita tadi, dia akan bergerak laju. So tak sempat dia nak diffuse. Dah bawa ke detektor, dah sampai detektor, tak sempat nak diffuse. However, if the flow rate is slow, bawa slow, so dia sempatlah diffuse. Dia sempat gerak ke kiri kanan. So you get band broadening. Okay, so that one is for packed column. For open tubular capillary column, so this is open tubular capillary column. So dia ada kat tepi je lah. Either wall contact directly ataupun dia ada solid particles kat tepi ni. Tapi kat tepi sahaja. Okay, but if you have packed column, ni packed column dia di tengah. So for open tubular column, there is no multiple path, or there is no eddy diffusion. So you can see that this one is more efficient lah untuk elakkan band broadening. So it just depends on B factor and C factor, longitudinal dengan mass transfer. A term dah tak ada. Okay, so open tubular capillary chromatography, it involves a sample being vaporized and injected into the head of the chromatography column. The sample is transported through the column by the flow of either inert gaseous or buffer solution as the mobile phase. So that we have two types of chromatography, gas chromatography and liquid chromatography. Sebenarnya we have actually three types of chromatography, tapi pada level kita belajar dua je lah, gas dengan liquid chromatography. So for gas chromatography, this one when your mobile phase is gas. So you're going to have gas chromatography or GC. Liquid chromatography when you have liquid mobile phase. Ataupun kita panggil solvent lah. So we are going to have LC, liquid chromatography.